example, simply take the dot product of the filter and the window of the input. And you keep sliding that window. Alright, so so I think about the filter now, that form. Okay. And now I really want to find out this arrow here. What does it look like? I want to look at that part. So, with that framework in mind, I now can write down the of n is simply equal to d of n minus h transpose times with x of n. This is a vector, right? It's a number. And now if I now have to take the expectation of epsilon and square, that equals the expectations of these two numbers multiplying each other. And this is equal to the d of n multiplied with this. So I can put that expectation. So now when I multiply these two, what do I have? I can have that equal to d of n squared minus 2 times h transpose d of n times with x of n and plus this thing here is so taking that vector multiplied itself will give you simply the x of n vector times with h x of n transpose times h transpose xn. Okay. You multiply these two, right? You multiply that. Remember when you multiply two numbers, you just multiply the vector with its transpose. Okay. So that is my expectations. I got that out. Okay. Now make the use now. So in here, I might do something wrong there. Not doing something wrong, maybe with this I wouldn't have something I would like to have. So maybe let me see here. The main trick here is I take the transpose of the other guy. So I take this, maybe let me do this. I'm going to take this. I take this, okay. Similar, I can take this x transpose times h. The same, right? I just take x transpose times h. So this thing here, I can take this x transpose of n times h. Okay. And now when I multiply this thing square, I got this square 2 times, doesn't matter what it could be, but maybe I can write this equal to 2 times, let me see, 2 times of d and multiply dn multiply. Okay. Maybe let me do it slowly. Maybe let me do it slowly. So let us see the multiplication. So I have this number, and that is what the expectation. Expectation now of when I multiply this, the way to multiply this is I take the dn minus x and vector transpose h, and to do the multiplication, what I do is I take the dn minus x and h vector here transpose. Right? That's the two things. But normally when we do this, because it is just a number, so what we normally do is we take one number and we take the transpose here. So we put a transpose here. It doesn't change my computation. And when I take the transpose of that, then this thing here can be written as d of n minus the transpose of this. I still couldn't get it right. You see, just see. Maybe I want to do the transpose of this. Take the transpose so that's more consistent. Always take the transpose of the first guy. Alright. Take the transpose down, and this vector here now I can be written as simply dn minus the transpose of the thing inside, which is going to be h vector, because checking the transpose, right? A product is the product of the transpose. Right? So h of t, and then I have x of n. Okay. Alright, so that first square bracket is done. Okay, are you comfortable with this? Alright. So that giving me now the expectation now of the thing inside that I want to. So that giving me the d of n, the square. This multiplied with that minus, so it will be 2 times of maybe I take this d multiplied with this. So 2 times of dn x of n transpose of h, and plus this thing, which is h transpose times x n times x n transpose times h. Okay. Still with it, right? Multiply that. Now, to do this thing now, I use the same trick that I use over and over again, which means I can, because it is linear sum, I can identify where the constant, and I can put the constant outside the expectation. Okay. I can put the constant outside the expectation. So to do that now, the mean square error, so the mean square error now equal to simply the expectation of dn squared minus 2 times of this. So the h here, the constant,